As with any geometry problem, we should start by drawing a diagram. In this problem, we're looking at a square called ABCD. So we're going to draw the square ABCD. And we're told that a circle of radius 2 and center E is inscribed in the square. Inscribed means it's inside the square, but it's touching the edges in such a way that it couldn't get any bigger. And the way that that has to work is that the center E has to also be in the center of the square. Now what we want to do is we want to find the area inside triangle ABE, which is this triangle, but outside of the circle. That's going to correspond to these little parts down here, because we're looking inside the triangle, but we're not counting the part that's inside the circle. The way that we do a problem like this, because the area is inside the triangle but outside the circle, we need to take the area in the triangle and subtract away the part in the triangle that's also inside the circle. So the area of what I'm going to call the shaded region is going to be the area of the triangle minus the part of the circle inside the triangle. That's a quarter circle. So that's the area of a quarter of the circle. Let's start with the triangle. The area of a triangle is 1/2 times the base times the height. Well, we know that the circle has radius 2. We can draw in this radius here. Because that's 2, we know the diameter of the circle's 4, which is also the length of the side AB. So 1/2 the base times the height is going to be 1/2 times the base, which is 4, times the height, which is 2. That's going to be 1/2 of 8, which ends up being 4. From that, we have to subtract the area of 1/4 of the circle. Now the area of a circle is going to be pi r squared, but because this is a quarter of the circle, this is going to be pi r squared over 4. We know that the radius is going to be 2, so this is going to be pi times 2 squared over 4. But 2 squared is 4, so we've got 4 over 4, which is 1, and all we're left with is pi. So we end up with the area of the triangle minus the area of 1/4 of the circle is 4 minus pi. So that's going to be our final area, and we can see that that corresponds to answer choice C.